You know, it's a question every single one of us has asked, probably since we were kids. Why is the sky blue? We see it every single day, but the answer, well, it's this incredible story about physics, and today we're going to solve it together.
I mean, really think about it. It's a color that's so constant, so present, we almost forget to even notice it. But that deep, beautiful blue is the result of an amazing journey that sunlight takes every second of every day just to reach our eyes.
So let's play detective for a few minutes. The sky is our big mystery. The clues are sunlight and the air itself, and by the end of this, we're going to crack this case wide open.
All right, our investigation starts right now. And you know, like any good mystery, the first step is to get to know our main suspects.
And in this story, there are really only two main players on the stage. You've got sunlight, which is speeding from about 93 million miles away, and you've got the very air, the atmosphere that surrounds our planet. The entire secret is locked up in how these two interact.
So first up, sunlight. Now, to us, it looks white, right? Maybe a little yellowish. But that's actually a trick. In reality, it's a mashup of every single color in the rainbow, all blended together. And this one fact, it is the absolute key to everything.
But here's where it gets really interesting. Not all of these colors are created equal. They have totally different, let's call them personalities. Blue and violet light are like these hyperactive little sprinters. They have short, buzzy, high-energy waves. On the other hand, red and orange light are more like chill marathon runners, with these long, lazy, lower-energy waves. This difference is everything.
And our second player, the atmosphere. It's not just empty space up there, you know. It's this huge sea of tiny gas molecules, mostly oxygen and nitrogen. It's like an invisible obstacle course that sunlight has to navigate to get down to us.
So we've got our energetic blue light and our more relaxed red light. And they're both just barreling into this sea of air molecules. So what happens when they collide? Well, that is where we find our solution. It's a phenomenon called light scattering.
Okay, so the fancy science name for this is Rayleigh scattering. But don't let the name fool you. The idea is actually wonderfully simple. When a particle of light smacks into an air molecule, it gets bounced off in a new direction. But, and this is the game changer, this happens way more to that zippy, high-energy blue light than it does to the long, lazy red light.
I love this analogy. Think of it like a giant cosmic pinball machine. The red light particles are like heavy steel balls. For the most part, they just plow straight on through all the obstacles. But the blue light particles, they're like those super bouncy, lightweight balls that just ricochet off everything, scattering in every possible direction.
So with all of that blue light just scattering everywhere, up, down, sideways, all around, our entire atmosphere is literally filled with it. So no matter which direction you look up, some of that scattered blue light is heading right into your eyes. And that's it. That's why the sky is blue. Simple, right? Well, hold on. There's one more little twist in the case.
Just when we think we've totally solved it, our investigation hits a little snag. It's a really smart question, actually, and it shows there's even more to this story. Seriously, think about it for a second. If the rule is that shorter wavelengths scatter more, and violet has an even shorter wavelength than blue, shouldn't our sky be a deep violet color? It's a fantastic question, and the answer is this perfect two-part punchline that makes the whole thing even cooler.
So it turns out there are two key reasons. First, the sun itself just doesn't produce as much violet light as it does blue light to start with. But here's the kicker. The second and maybe more important reason has to do with us, our own eyes. The detectors in this whole experiment are just way more sensitive to blue. So yeah, there's some violet light scattering around, but our brain is pretty much hardwired to see a brilliant blue sky.
Okay, so now that we're all basically experts on light scattering, here is the really amazing part. This one single idea doesn't just explain the blue sky. It also perfectly solves the mystery of its gorgeous counterpart. Believe it or not, those fiery reds and oranges you see in a beautiful sunset, they're caused by the exact same physics. The only thing that changes is one simple, crucial variable: distance.
At midday, the sun is high up, right? So its light takes a pretty short, direct path down to us through the atmosphere. But as the sun sets and gets low on the horizon, its light has to travel sideways through a much thicker slice of that atmosphere to reach our eyes.
Think of it like a race again. That high-energy blue light is a sprinter. It scatters really fast and really powerfully, but it just doesn't have the stamina for a long-distance run. Over that huge journey at sunset, pretty much all of the blue light gets scattered away in other directions before it can ever get to you.
So what's left at the finish line? Only the marathon runners. Those tougher, longer wavelength colors like orange and red are the only ones that can survive that epic trip, and they arrive to paint the horizon in those incredible sunset colors.
And there you have it. We've solved the case of the blue sky, and we've cracked the mystery of the red sunset. And it all boils down to one simple, elegant, beautiful idea.
Isn't that just incredible? The entire color palette of our day, from that bright, cool blue of noon to the warm, fiery red of dusk, it's all painted by this one single process. A simple dance between light and air with a result that's just stunningly beautiful.
And this leaves us with one last, kind of mind-bending thought to ponder. We know why our sky is blue, but what if Earth's atmosphere was made of different gases? Or what if it was much thicker or thinner? What color would our sky be then? It's a pretty powerful reminder that the world we see is just one of infinite, beautiful possibilities. Something to think about the next time you look up.